All right, now we're going to look at dividing polynomials. So in one way, you've almost been doing this already. We've started with polynomials and we've factored them. So if I think about rearranging this scenario implies that x squared minus 5x plus 6 divided by x minus 2 is equal to x minus 3. Because if this times this multiplied makes this, well, I can do the reverse. So we can factor things that are quadratic and sort of simple for us to see. But when factoring is not easily done, we can think about long division. So first, let's think about whether a given binomial is a factor. So is this a factor of, is x minus 2 a factor of this cubic? Well, think about if this is a factor, then that means that x equals 2 is a root, and being a root would imply that if x equals 2 is a factor, if x equals 2 is a root, then 2 cubed minus 5 times 2 squared plus 4 times 2 minus 2 should be equal to 0. So let's test it. It's going to be 8 minus 20 plus 8 minus 2. So 8, that's 4 is 20, 8 is 2. That is not equal to 0, so x minus 2 is not a factor. That means that when I divide, I'm going to end up with some sort of remainder. So let's think about division. Well, first of all, let's think about dividing, let's say 117 by 4. So I first think, does 4 go into 1? No. Does 4 go into 11? Yes, and it goes in twice. 2 times 4 is 8. Draw the line, change the sign is how I learned it. And then I subtract. 11 minus 8 is 3, and bring down the 7. So now 4 goes into 37 9 times. I get 36, draw the line, change the sign, and I have a remainder of 1. So in the end, I say that 117 divided by 4 is equal to 29 and 1/4, because that's my remainder over my coefficient. The and 1/4 is like I've added my remainder over my divisor. So down here we have a little hint reminding you of vocabulary. So 117 would be my dividend, 4 is my divisor, and in the end I get a quotient. So 29 is my quotient, and then I get my remainder over my divisor. So let's see what happens when we think about this same sort of process with a polynomial. So the first thing I asked myself was, how many times does 4 go into 11? Or 4 times what gives me the closest thing to 11? So I'm going to start that by looking at my x. So x times what gives me x cubed? Well, I know that's going to be x squared, so I'm going to line it up over here above my x squared. And now I'm going to multiply x squared times x, just like we did with 2 times 4 gave us 8. So x squared times x is x cubed. I'll line that up, my like terms. X squared times negative 2 is negative 2x squared. And now I'm going to draw the line and change the sign. So draw the line and subtract all of this, which means that will be negative and this becomes positive. Then I'll combine. So x cubed minus x cubed cancels. Negative 5x squared plus 2x squared is negative 3x squared. So now I'm asking myself, x times what will give me negative 3x squared? That's going to be a negative 3x, so my x's line up. I multiply negative 3x squared plus 6x. These terms drop down, 4x minus 2. Draw the line, change the signs. So draw, change, change. That's going to cancel, and always we should have cancel, cancel. So 4x minus 6x is negative 2x. Bring down the minus 2. So I'm asking myself, what times x is negative 2x? That's negative 2. Multiply out, negative 2x plus 4. Draw the line, change the signs. Cancel. Negative 2 minus negative 4 is negative 6. Now, x times what makes negative 6? Well, I would have to do negative 6 over x, which is not a rational term. So up here I only want to, sorry, that is a rational term, and up here I want to have only monomials or polynomials. So no x's in the denominator. This is now my remainder. So if I'm going to write out my division, I have x cubed minus 5x squared plus 4x minus 2 divided by x minus 2 equals the quotient and then plus remainder over divisor, except I'll have plus negative 6 over divisor, x minus 2. So think about what this really means, that what I'm saying is this function, that was my original f of x. If I multiplied this divisor through to the other side, I would get that x cubed minus 5x squared plus 4x minus 2 is the same as x minus 2 times x squared minus 3x minus 2 minus 6. Well, if I multiply my divisor by this, that's going to cancel with the divisor in the bottom. So I can always check if my division is true, because now I can verify. If I expand this, I'm going to get x cubed minus 3x squared minus 2x squared is minus 5x squared minus 2x minus 4x, minus 2x plus 6x is going to be plus 4x. Negative 2 times negative 2 is positive 4. Minus 6 is going to be minus 2. So it checks. So this is my division algorithm, that f of x equals divisor times quotient plus remainder, or f of x divided by d of x is equal to quotient plus remainder over divisor. This is like my 117 over 4 equals 29 plus 1/4. One last thing, my remainder theorem says that if the remainder is 0, my divisor is a factor. So if we ended up with 0 here, everything would cancel, and I would have just a perfect factor. It's the same thing, it's similar to what we set up here. So this is my remainder theorem.